Ever pondered about the physics, the engineering, the sheer technical brilliance that propels SpaceX's Crew Dragon to the International Space Station? Ever wanted to take a seat and experience it yourself? Guess what? I've got a ticket here just for you. Join me on your in-depth exploration into the intricacies of space travel. I'll walk you through the power of the Falcon 9, the precision necessary for a successful ISS docking, and the science behind a controlled and safe re-entry into Earth's atmosphere on your own flight to the ISS and back. From launch pad to low Earth orbit, from space rendezvous to splashdown, I decode the complexities behind each stage of the mission as if you were a part of it all. This isn't just a marvel of modern science, it's a testament to human innovation. Join me as we peel back the curtain on SpaceX's technological tour de force together. Welcome to Dragon's Flight, your SpaceX Odyssey. Let's dive right in. My name is Felix, welcome to What About It? Let's discover together how SpaceX's Dragon capsule became the space Uber on your very own flight to space. Welcome aboard. Our journey to the ISS begins at Cape Canaveral Air Force Station's processing facility, where every Crew Dragon is prepared for flight. SpaceX's Crew Dragon is a complex beast. One thruster just isn't enough to safely get to the ISS and back again. We're not playing Lunar Lander here. SpaceX's capsule is equipped with 18 small Draco thrusters necessary for orbital maneuvers and 8 Super Draco engines serving as a launch escape system. These engines utilize monomethyl hydrazine and nitrogen tetroxide, highly toxic yet simple to use and extremely reliable compounds. Unlike Falcon 9, whose fueling occurs shortly before launch, Crew Dragon's propellant toxicity necessitates the fueling to happen at the Air Force Station long before the actual flight. You might recall that SpaceX initially planned to build a new capsule for every mission, reassigning the used capsule to cargo missions afterwards. This idea, however, was quickly scrubbed. Instead, SpaceX decided to make all Crew Dragons reusable. Thus, the majority of capsules here are refurbished ones that have been to space before. Currently, in the Dragon's den, there are 4 majestic beasts: Endeavor, Resilience, Endurance, and Freedom. Although the company has halted the production of new capsules, one Crew Dragon, called C213, is still under construction. Upon its completion in 2024, it will join the others to be fueled at the Air Force Station facility. Once ready, Crew Dragon is transported to SpaceX's Horizontal Integration Facility hangar at Florida's Launch Complex 39A. If you ever wondered, it's that hangar right next to the pad. Currently, this is the only launch pad in the world capable of launching crewed SpaceX missions. This may change soon though, as SpaceX's engineers are already working on outfitting another launch complex, Slick 40, with a special tower, enabling SpaceX to perform additional crewed launch opportunities and to have a backup for, let's say, if a Starship spontaneously decides to have a blast at Pad 39A in the future. Once the capsule arrives at the LC-39A's hangar, it's hoisted and mated with Falcon 9's second stage and booster. While NASA initially had reservations about SpaceX flying people on reused boosters, over time these concerns faded away. The Crew 2 mission already reused the first stage B-1061, which also launched the Crew 1 astronauts into space. The rocket, now mated with the Dragon, is rolled out to the pad and erected. Unlike other companies, SpaceX employs a meticulous approach to testing. A single failure or launch escape system activation would disrupt their launch schedule for months. Therefore, most Falcon 9s undergo a static fire before each mission, showing SpaceX's commitment to safety and accident prevention. After a successful engine test, the vehicle is ready to launch with you and your crew on board. For the purpose of this video and to keep it as easy to understand as possible, we'll utilize the same profile as NASA's crew missions, as flights like Inspiration 4 were one-offs and they all will have different flight profiles. During launch day, the launch crew is busy to say the least. Dragon preparations start approximately 5 hours before the liftoff, as the capsule is powered on and configured for flight. At around 4 hours and 5 minutes prior to ignition, NASA hands you and your crew over to SpaceX. There, teams perform a series of critical pre-flight procedures, including suit checkouts, ensuring you and the other astronauts' safety during your voyage to space. Now we're getting closer to the moment every astronaut is looking forward to. Your nails are freshly chewed down and you're absolutely ready to risk it all. True astronaut, well done. 3 hours and 15 minutes before liftoff, you're escorted to Launch Complex 39A. Your means of transport, a sleek Tesla Model X marked with NASA's emblem, which symbolizes SpaceX's modern and sustainable approach to space exploration. Did you know that you're driving up the very same ramp that is used to transport the rocket? Arriving at the tower, you and your crew can take a quick glance at the sheer size of the rocket you're about to board. Selfie time! Then, with approximately 2 hours and 35 minutes to lift off, you ride the elevator by pressing the button that says space on it, and then you enter the capsule. Excited? There are more people involved in this than just you though. Let me introduce you to some of the unsung heroes of our space adventure, the enigmatic figures dressed in black, the SpaceX Ninjas. They are there to ensure that you're correctly seated, comfortable, and hooked up to your life support system. Think of them as your unusually dressed pre-flight attendants. They sport their all-black ensemble not for the cool factor, even though it definitely has that. Instead, it's to prevent FOD or foreign object damage. Imagine a nasty tiny screw, for example, playing havoc in space. It doesn't take much, you get the idea? The Crew Dragon 2 has covers to prevent FOD. Once these are removed and all systems get a green light, it's hatch closure time, and yes, it's as meticulous as you'd think. You see, we need that compartment as airtight as a drum to keep you safe. Any leakage, and it's a disaster movie with you in the leading role waiting to happen. Pressure is raised slightly inside the capsule to confirm this process. Good seal confirmed, now you're on your own. Roughly 70 minutes before the countdown reaches 0, Dragon gets updated International Space Station coordinates. This is followed by a crucial go-no-go poll. It's the final check to confirm that the Dragon is ready to soar. So what if something goes sideways in this final hour? Is there any plan B for you to live another day? Of course there is. If they hit a snag before hatch closure, you can make a quick exit courtesy of the tower's elevator. In case that elevator acts up, you and your crew can zipline down via a high-tech basket system, a nostalgic nod to the space shuttle era. Never change a working system. The crew tower is also equipped with a fire suppression system, so that's one thing less to worry about. Once the hatch is sealed and the crew access arm retracts 42 minutes pre-launch, the escape plan gets a bit more Hollywood-like. At T-minus 37 minutes, the Crew Dragon's escape system is armed. If the fueling process sparks any trouble, this escape system, faster than a firework, can catapult the capsule away from the rocket even while it's still sitting on the pad. Comfortable? Not quite, as the peak acceleration force you'd have to endure during this escape can reach over 3.5 Gs. But it undeniably beats the alternative of becoming a human toast in an explosion. In your case, and so far on every SpaceX Crew Dragon launch, everything goes according to the plan. Phew! The final preparations mirror the standard Falcon 9 fueling procedure, as both the booster and second stage are pumped full of liquid oxygen and RP1. You can feel the rocket come to life under your seat. Then the moment of truth, liftoff. You and your brave crew blast off into space. Excitement guaranteed, but you've seen nothing yet. Just a minute later, you encounter Max Q, the point of maximum dynamic pressure. Here, the spacecraft faces the greatest mechanical stress. If there were any structural flaws in the rocket or the capsule, Max Q would be the ruthless revealer. Then it's pedal to the metal, and following this, Falcon moves into separation, second stage ignition, and first stage landing. So far so good, you're alive. By T plus 12 minutes, Dragon is set free and its nose cone is unlatched. Suddenly it's much more silent and much more weightless in your capsule. But why does Dragon need a nose cone, and why open it so early into an up to 24-hour journey? Brilliant question, a little late into the flight, but hey, thanks for asking. The nose cone serves a dual purpose. It shields the docking adapter, Draco thrusters, and the forward hatch as the rocket slices through the atmosphere, while also maintaining an aerodynamic shape for a smooth flight. But why open the nose cone so early? Well, if it jams, you can't dock with the station. Thus, it's better to discover any potential hitches right off the bat instead of wasting precious hours only to realize docking is off the table. On you go. Roughly 45 minutes post liftoff, Dragon activates its Draco thrusters for a phase burn. This maneuver raises the Dragon's orbit close to that of the ISS. Now you can conduct mission tasks or just chill, as the next thruster firing isn't slated until around the 9 hours and 50 minutes mark. This time, the boost burn raises the spacecraft's apogee to be just 10 kilometers or 6.2 miles under the ISS. A short 40-minute break later, Dragon performs another burn to circularize the orbit, meaning that its orbital apogee and perigee closely mirror each other. Depending on the flight profile, several hours on, a transfer burn takes place, lifting Dragon's apogee to a mere 2.5 kilometers or 1.55 miles beneath the station. Now we're getting to the spicy part. Once Dragon is just 7.5 kilometers or 4.66 miles away from the ISS, I'm talking about distance, not apogee, another go-no-go poll is conducted. This safety check is needed because you're getting close to the so-called approach ellipsoid, an egg-shaped zone measuring 4 by 2 by 2 kilometers or 2.5 by 1.5 by 1.5 miles. When approaching this zone, Dragon must maintain a safe trajectory, ensuring that in the event of losing all its propulsion, it would take 24 hours before you would pose a threat to the ISS. This is a safety measure, giving the team time to brainstorm an emergency plan in case something goes terribly wrong. Excited? At this point, Dragon establishes a communication link with the station, allowing the Earth-based mission control to receive the capsule's telemetry through the ISS as a backup. Once the capsule enters the approach ellipsoid, it will be held at yet another point, waypoint 0. It's what's known as the ISS's keep-out zone, a 400 meter or 0.2 mile diameter sphere that has the identical function as the previous one. This time, the approaching spacecraft trajectory can't be on a crash course with the station for at least the next 6 hours or precisely 4 orbits. Assuming everything remains on track, Dragon performs another burn, taking you to waypoint 1. Positioned 220 meters or 722 feet from the station, this is where the capsule aligns its own axis with the docking port axis of the ISS. Almost there now. At present, the ISS houses 2 docking locations compatible with the Crew Dragon. The forward and the zenith ports of the ISS's Harmony module have been retrofitted with international docking adapters. A standard design that allows docking from vehicles of various private companies. For now, though, both these ports are mainly used by SpaceX. Once waypoint 1 is achieved, Mission Control conducts another go-no-go poll to determine if you and the crew are safe to dock with the station. It should be clear by now that this approach phase is executed with extreme caution. Dragon is taking it step by step when being so close to the ISS. Should the signal be a go, Dragon proceeds to waypoint 2, a mere 20 meters or 65 feet from the station. You can now see the ISS through your capsule windows. Dragon slowly starts to approach the docking port. Docking itself is divided into 2 steps. First, a specialized ring catches the capsule, completing a step known as soft capture. The system then draws the capsule closer, allowing 12 hooks to latch onto the station in a process known as hard capture, which completes the second step. All these complicated maneuvers are done fully autonomously by the spacecraft itself, leaving you to simply monitor the data and enjoy. This stands in contrast to the original Dragon, which used a system known as berthing. In that case, Canadarm2, the robotic arm attached to the ISS, would latch onto the vehicle once it neared the docking port, and astronauts on board the ISS would manually dock it. Upon completion of further checkmarks, you, the spacecraft commander, then pressurize the vestibule, a space between the ISS and Crew Dragon, protecting both teams from the void of space. During this time, data and video umbilicals are also connected. Following a final leak check, Dragon's forward hatch is at last opened and you are welcomed into the station by the ISS crew. The time from liftoff to docking can span from 16 to 24 hours. You might wonder how Dragon can take a full day to reach the ISS while the record time for a Soyuz capsule is just 3 hours and 3 minutes or merely 2 orbits. The truth is, if SpaceX and NASA so desired, they could reduce this time to single-digit hours. However, Roscosmos has an edge here due to its extensive experience. The entire Soyuz family has already scored over 140 crewed missions. They've had ample opportunity to refine their rendezvous plans for speedy docking. In the ISS's early days, Soyuz took nearly 2 days to dock. Over time, this period has been whittled down, reaching a 6-hour docking time and eventually a 3-hour docking window spanning just 2 orbits. NASA opts for a cautious approach, favoring longer maneuvers that offer better control and additional response time in case of an emergency. That doesn't mean that we won't see faster docking times in the future. Once Dragon is securely docked, astronauts typically remain on the ISS for about 6 months. SpaceX's taxi has the capability to stay in space for 210 days when docked at a station and 10 days in free flight. It probably won't surprise you that Crew Dragon also possesses the capacity to relocate from one docking port to another autonomously. As a fun fact, you and your crew still must be on board during this operation, as any emergency could potentially leave you stranded on the station. Now let's get to the hot part. After the mission's conclusion, you must somehow return to Earth. So let's pack our bags and head back home. Once the weather on Earth is good enough and a primary and backup landing sites are chosen by the mission control, our Dragon is ready to return home. After packing all the necessary gear and cargo, you settle into your seats, the door is closed, and Dragon releases its hold on the International Docking Adapter. Next, a sequence of burns is carried out in quick succession to distance itself from the station. The first of these maneuvers is the Depart Burn 0, taking place immediately after undocking. For 16 seconds, the Draco thrusters situated in the front of the capsule are engaged, moving the capsule in an upwards direction away from the station. 5 minutes post undocking, Depart 1 commences, a brief 21-second firing that clears the keep out and approach spheres. This is followed by a series of mission-specific burns determined mostly by the chosen landing site. Dragon has to aim for the right spot down there. But where can you park a Dragon? Where is a Crew Dragon allowed to land? We have 7 parking spots available for you right now. SpaceX is equipped to facilitate capsule splashdown at 7 different sites located off Florida's east coast and in the Gulf of Mexico. These are the sites available to you and your fellow brave astronauts. The one that's best for each flight and each slightly different situation is chosen. Getting closer to home, and regardless of the flight profile chosen, you hear a clunky sound and the trunk is jettisoned 5 minutes before the deorbit burn begins to prevent the capsule from colliding with it during atmospheric re-entry. Following the trunk's jettison, the 12-minute deorbit burn starts. Once again, utilizing Draco thrusters located inside the nose cone of the capsule. Why doesn't SpaceX just use the Super Draco engines for this phase? They are extremely powerful, and since they are pointing down already, the capsule wouldn't need to adjust its attitude. Would that be faster? Let's see. While it is technically doable, Super Dracos weren't designed for space operation, meaning that they have low efficiency in a vacuum. Additionally, they are beasts. A single Super Draco thruster provides 177 times the thrust of a standard Draco. Such a burn would need to be incredibly short, merely a second or 2. Anyone who has played Kerbal Space Program knows exactly how easy it is to overshoot your target during such short burns. Using lower thrust engines makes precise maneuvers much easier and safer to execute. Once this burn is completed, the Draco thrusters are no longer required, so the nose cone is again closed and latched. Minutes later, the most daunting phase of your entire journey begins. It's not the launch, it's the atmospheric re-entry. Several factors make this part particularly challenging. As Dragon enters denser portions of the atmosphere, it does so very fast. I mean, really fast. You're screaming through the sky. Its orbital speed is around 27,000 kilometers or 17,000 miles per hour. That is 20 times faster than a bullet shot from a pistol. Imagine moving at this speed toward the upper layer of our atmosphere. This needs to be shaved down to a mere 560 kilometers or 350 miles per hour within about 7 minutes, courtesy of atmospheric drag. During this process, the capsule compresses the air in its path. A shockwave forms around the capsule. This shockwave is what excites and significantly heats the gas molecules in the air around the capsule. Temperatures can escalate so much that the gas molecules dissociate into separate atoms and ionize, forming a plasma. Imagine sitting inside of an extremely hot plasma cloud. This glowing plasma is what gives re-entering spacecraft their fiery experience. Although this may sound useful, all the energy from re-entry must be dissipated to prevent the vehicle from burning up and getting ripped into pieces. To avert this, crewed vehicles typically employ ablative heat shields. While there are other methods of dealing with this heat, such as active cooling, these are currently in the realm of experimental technology. Go stoke space! Looking at the Dragon capsule, you'll notice numerous heat tiles. To comprehend why they are used, it's necessary to understand how ablative shielding works. An outer layer of an ablative heat shield is engineered to slowly burn away in a controlled manner, carrying the intense heat of re-entry away from the spacecraft. The ablated material forms a boundary layer of cooler gas, serving as an additional insulation against the hot gases flowing past the spacecraft. SpaceX uses an ablative material called phenolic impregnated carbon ablator, or PKX3 for short. For short. It's their own derivative of NASA's PK, which was utilized for missions like Stardust and Mars Perseverance. Fun fact, reportedly Elon Musk's version is 10 times cheaper than the original. During re-entry, when plasma engulfs the vehicle, the spacecraft enters what's known as a blackout period. It's the most nerve-wracking part of the entire mission since all communications are blocked. This means ground control can't monitor Dragon's telemetry and you have to pray everything is proceeding as planned. Fortunately, this phase only lasts for an agonizing 7 to 10 minutes. Once the vehicle decelerated enough at an altitude of 5.5 kilometers or 3.4 miles, Dragon deploys 2 drogue parachutes. It's accompanied by a loud noise, you won't miss it. These small parachutes are designed to orientate and stabilize the vessel, as well as slow it down enough to enable the deployment of the main parachutes. When the capsule slows down to 450 kilometers or 280 miles per hour at an altitude of 2 kilometers or 1.25 miles, the main parachutes are deployed. These chutes further slow the vehicle down to 25 kilometers or 15.5 miles per hour, after which the capsule lands in the water at one of the landing sites. The Crew Dragon parachute system is designed to operate safely even with one chute out, meaning the capsule can land safely with only 3 parachutes. Here's the next important question. Can Dragon at least use its Super Draco engines as a backup landing method? I mean, remember, 170 times the thrust of a Draco. Unfortunately, that's not feasible either. In the past, Dragon was actually supposed to land using its engines. But as you've probably already guessed, NASA wasn't particularly fond of this idea, especially considering the proven safety of parachute systems. While Elon Musk did mention in 2019 that such a landing would be possible, to my knowledge, the Dragon's software does not include any landing modes that involve the use of its engines. So even if they wanted to, the Dragon capsule would be missing the programming code to execute the maneuver. Opting for the traditional water landing simply offers greater safety. However, it does necessitate additional efforts to recover the capsule. Let's stay in character. After all, you're not home yet, right? Splashdown. You're in the Gulf of Mexico or in the Atlantic Ocean, being happy you didn't burn up. For this purpose, SpaceX has acquired 2 recovery vessels. Megan and Shannon to the rescue. Twin ships that are essentially mini operation centers, complete with a full medical treatment facility, communication radar, lifting crane, and helipad. Once the capsule splashes down, 2 smaller boats are deployed. The first one inspects the integrity of the capsule and ensures there are no toxic hypergolic propellant vapors present. Simultaneously, the second one retrieves the capsule's parachute, which by this point has already detached. Then the main recovery vessel moves in and hoists the capsule onto the ship's deck. Next, SpaceX personnel fully equipped with protective gear seals the thrusters to prevent the toxic fuel from escaping. Venting equipment is then affixed to the nose cone to dissipate any residual hazardous fuel further. Finally, the side hatch is unlocked, a protective piece is put in place, and you are assisted in exiting the capsule. After spending half a year in space, even with daily exercises to mitigate muscle weakening, astronauts can still struggle to stand on their own, and hence they are often carried away. I'll leave the decision to you if you could walk away from this on your own. Immediately following this, you receive a medical checkup. It's rare that anyone requires immediate medical attention, but as the saying goes, it's better to be safe than sorry. Finally, you and your crew are transported via helicopter to shore, where you will eventually reunite with your family. As for the capsule, it is brought to Port Canaveral and later refurbished at Cape Canaveral Air Force Station. Details about the refurbishment process are somewhat scarce, but we do know that the ablated Pika X heat shield is replaced, as well as panels made from SpaceX's proprietary ablative material, or SPAM for short. The parachutes are also changed. Once the capsule is ready, it's refueled with monomethyl hydrazine and nitrogen tetroxide, and the cycle you just went through restarts. Right now, Crew Dragon Endeavour holds the record for the most reused Dragon capsule with 4 flights under its belt. Theoretically, one capsule can be reused up to 15 times, and even though SpaceX has halted its production, Crew Dragons are far from retirement. NASA has already scheduled missions up to Crew 14, indicating that the Dragon will likely serve as the ISS's space taxi until the station's projected decommissioning in the 2030s. In my opinion, it's highly probable that it will also play a significant role in the development of SpaceX's newest project, Starship. Given the problematic nature of launching humans on this massive ship, Crew Dragon could be used to transport the crew from Earth to Leo, where they can board the Starship. Now you understand the enormous amount of engineering needed to bring the Dragon to space and back. We hope you enjoyed your flight. Thanks for traveling with Why and SpaceX. That's it for today. Remember to smash the like button and subscribe for more awesome content. Check out our epic shirts in your favorite Space Nerd store. A link is in the description. And if you want to get even smarter about space and rockets, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again in the next episode. Retrofitted. It's not so hard. Finally, tetroxide. Ha!